If n equals 1, the proof starts by saying that, when there is only one variable, we take the identity automorphism. Why is that enough? Because in one variable, every non-zero element of the Tate algebra is already distinguished of some order. So there is nothing to construct. The statement is already true with no change of variables at all. So from now on the proof only needs to treat the case where there are at least two variables. Fix the exponents and define the map. Now the proof fixes some natural numbers, one for each variable except the last one. Then it defines new elements by replacing each variable except the last with itself plus a suitable power of the last variable, and keeping the last variable unchanged. Then, for a general series, the proof defines its image by replacing each monomial with the corresponding monomial in these new generators, keeping the same coefficients. Why is this the natural definition? Because an algebra map is determined by what it does on the variables. Once the images of the variables are fixed, the only reasonable way to define the image of a series is to substitute those new generators into each monomial. But now a real question appears: why does this infinite substituted series still converge in the Tate algebra? That is exactly what the next lines check. Norm of the new generators. First, the proof looks at the last new generator. It is just the last variable itself, so its norm is 1. Then it looks at one of the other new generators. It is the sum of two terms, the original variable and a power of the last variable. The proof says its norm is at most 1. Why? Because of the ultrametric triangle inequality, the norm of a sum is at most the maximum of the norms of the summand. Each summand has norm at most 1. The variable has norm 1, and the power of the last variable also has norm 1 because the norm is multiplicative. So the norm of the sum is at most 1. Then the proof immediately says the norm is actually equal to 1. Why can we improve at most 1 to exactly 1? Because in that series the coefficient of the original variable is literally 1. The Gauss norm is the supremum of the absolute values of the coefficients, so it cannot be smaller than 1. Since we already knew it was at most 1, it must be exactly 1. So every new generator has norm 1. Norm of the substituted monomials. Now the proof considers any monomial built from these new generators. Since each generator has norm 1, and the norm is multiplicative, the whole monomial also has norm 1. Then the proof multiplies by the original coefficient and concludes that the norm of the whole term is exactly. Substituted terms are controlled exactly by the original coefficients. That is what allows the convergence argument to go through. Is Cauchy. The proof next uses the defining property of an element of the Tate algebra: the coefficients go to 0. Since each substituted term has the same norm as the corresponding coefficient, the norms of the substituted terms also go to 0. Now look at a finite tail of the substituted series. The ultrametric estimate for finite sums says that the norm of that tail is at most the maximum norm among the terms in the tail. But those term norms go to 0 because the coefficients go to 0. So the tails go to 0. That means the substituted series is Cauchy. Since the Tate algebra is complete, every Cauchy series converges. Therefore the image really belongs to the Tate algebra, so the map is well defined. Why the map is contractive? Next, the proof estimates the norm of the image of a series. It applies the ultrametric estimate for convergent